Perfect squares are one of those expansion and factorising patterns that you should be able to look at and know how to do by sight without any working necessary. Perfect squares are actually also really important because later on when you go to factorise quadratics, perfect squares can be used if you use the completing the square method. Sometimes it's even used in the method that people like to refer to as splitsies. So let's take a look. As always, we start by expanding. Now, a common mistake people make when expanding these brackets is they assume automatically that it's x squared plus 9. That's not the case. You need to remember that this entire bracket is being squared. When we square something, we multiply it by itself. So we're left with x plus 3 multiplied by x plus 3. If we expand this bracket, and once again, feel free to use your arrows. That's a strategy that you should feel comfortable using all the time if you cannot just look at it and know what the expansion is. So this gives me x squared plus 3x plus 3x plus 9. We collect our like terms and we end up with x squared plus 6x plus 9. Let's take a look at this one now. We'll explain what we've seen. Hopefully you do start to see a pattern between all three once we've done all of them, and then I'll talk it through and tell you about the general rule. So once again, this is not just x squared minus 25, it's x minus 5 multiplied by x minus 5, which equals x squared minus 5x, so this time it's a minus, plus 25. Remember, a negative times a negative is a positive, so I've got plus 25. When I collect like terms, I end up with x squared minus 10x plus 25. So hopefully what you can see here is we've got this squared, we've got that squared, and then we've got two lots of this number. 2 times 3 is 6. 2 times negative 5 is negative 10. So hopefully you can start to see that pattern. So what I should do over here now is I should be able to see that 7 squared is 49 and 2 times 7 is 14. So I know that this is the same as x plus 7, and they're both positive, therefore it's plus 7 all squared. So what we can do is we can come up with a general rule, and we can say that a plus b all squared equals a squared plus 2ab plus b squared. The same can be said if we've got a negative. If I've got a minus b squared, that will change our middle term. So then I end up with a squared minus 2ab plus b squared. So they are the general rules that we can use for perfect squares, whether we are expanding or factorising.